Hello friends, in the previous lecture we have seen that what is meant by binary operations. So let us we have to take one more example on binary operation. So let us start. First question, for each of the binary operation, for each of the binary operation star, for each of the binary operation star, define, for each of the binary operation star, define, determine whether star is commutative, determine whether star is commutative, determine whether star is commutative, and whether star is associative, and whether star is associative. What is your question? For each of the binary operation star, define, we have given binary operation star, determine whether star is commutative and whether star is associative. So your first example is on Q. What is my Q? That set of a rational number. On Q, define, on set of rational number, define star by A star B. On set of rational number, define star by A star B equal to AB plus 1. Define star by A star B equal to AB plus 1. Here A and B are members of Q, that is set of rational number. Okay, this is your question. We want to check that whether star is commutative and associative. So let us start solution of first example. Adam, let A comma B belongs in Q such that A star B equal to AB plus 1, polynomial equation 1. Okay. What I am writing? Let A and B are any rational numbers such that A star B equal to AB plus 1, that is your given poly equation 1. Okay. For commutative, first one for commutative, check that star is commutative. Okay. So let consider A star B equal to, consider A star B equal to, what is your A star B? That is your AB plus 1. Okay. What is your A star B? AB plus 1. Okay. Therefore, where A and B are members of rational number, okay, then AB, which is can written as BA, right? Because multiplication is commutative in rational number. Because multiplication is commutative in rational number. Because AB can be written as BA plus and BA plus 1 analysis. So this is your B star A. Okay. So we get A star B equal to B star A. What is B star A? That is BA plus 1. So we get A star B equal to B star A. Therefore star is commutative on Q. You know? Therefore star is commutative. Star is commutative on Q. Right? Star is commutative on set of rational number. So second, for associative. Okay. Second property, we have to determine whether star is associative. Okay. So let A comma B comma C, all these three are your rational number. Consider for associative, we have to consider A star inside bracket B star C. Okay. We have defined that A star inside bracket B star C. Okay. So your A as it is, star is your as it is. What is the value of B star C from equation 1? Equation 1 given that A star B equal to AB plus 1. That two elements take this product and add with 1. Similarly, B star C is become BC plus 1. Take at bracket. Okay. So now we have to find the star of that two value. Okay. We have to find star of that two value. What is star of that two value? From equation 1, star of that two value means take product of that two value. That is A into BC plus 1 as it is. Okay. From equation 1. What is star of that two value? From equation 1, it gives that star of that two value become take product of that two value plus add with 1. Okay. Now simplify this one. So we get A into BC become ABC plus A plus 1. Okay. This is your value of A star with B star C. Okay. Now similarly consider A star B against star with C. Okay. Similarly, consider A star B against star with C. Okay. So what is the value of A star B? From equation we deduce that AB plus 1 against star with C. Okay. Next step, we want to take star of that value. So what is star of that value? It gives that product of that value, that is AB plus 1 into C plus 1. Okay. From equation 1. What is star of that value? Take product of that value as it is plus 1. Okay. Now simplify this one. AB into C that will become ABC plus C into 1 become C plus 1. So this is your A star B plus star with C. Okay. Now call as equation 1, call as equation 2 and call as equation 3. Okay. Now from equation 2 and 3, is it both are equal? From equation 1 gives that ABC plus A plus 1. From equation 3, what do you write here? ABC plus C plus 1. But A is not equal to C. Okay. So therefore from equation 2 and 3, 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 we get, from equation 2 and 3, we get A star with B star C is not equal to A star B against star with C. Okay. From equation 2 and 3, we get A star inside bracket B star C is not equal to A star B star with C. Okay. Therefore, star is not associated. Star is not associated on set of rational number. Okay. This is your two property for your first example. Okay. So similarly, take a second example. Similarly, take the second example. On Z plus, what do you mean Z plus? Set of positive integer. Okay. On Z plus, define star by P star Q. On your Z plus, that is set of positive integer, define star by, that is binary operation, is defined by P star Q equal to P raised to Q plus 2, where P and Q are your member of Z plus. That means P and Q are your positive integers. Okay. Where Z plus is set of positive integers. What do you mean by Z plus? Where Z plus is set of positive integers. Now we have to check that whether star is commutative and star is associative. Okay? So let us write the solution. Same procedure. Let P comma Q belongs in your positive integer such that let P comma Q are members of Z plus, that is positive integer, such that P star Q equal to P raised to Q plus 2 and call as equation 1. What is equation 1? P star Q equal to P raised to Q plus 2 called equation 1. Okay? Now we want to check that whether star is commutative and whether star is associative. So for first condition, for commutative property, okay, let P and Q are members of Z plus. Okay, so for commutative, we want to check that P star Q equal to Q star P. If they are equal, then star satisfies commutative property. So consider P star Q equal to, what is P star Q? That is P raised to Q plus 2, called equation 2, and consider Q star P equal to, what is Q star P? From equation 1, it gives that first member of power of that second plus 2, that is Q raised to P plus 2, called equation 3. Okay. Now from equation 2 and 3, what do you write as of equation 2? That is P raised to Q plus 2. What is equation number 3? That is Q star P is Q raised to P plus 2. So equation 3 of right hand side is Q raised to P plus 2. So both are equal? No. So from equation 2 and 3, so from equation 2 and 3, then we get, from equation 2 and 3, we get P star Q is not equal to Q star P. Why these are not equal? Because P raised to Q plus 2 is not equal to Q raised to P plus 2. Okay? So now second condition, for associative, we have to check that P star with Q star R. Okay? For associative, let P, Q and take one more element, that is R, is a member of Z plus, that is positive integer. We have to consider P star again Q star with R inside bracket. Okay? For commutative, for associative, we have to check that P star inside again Q star R is equal to P star Q bracket complete and the star with R. If they are equal, that satisfies associative property. For this, we have to render P star inside bracket Q star R. Okay. So therefore P and star here as it is. What is the value of Q star R? From equation 1, it gives that Q star R become, that is Q raised to R plus 2. Right? That second element of power. First element, its power become second element plus 2. Right? That is your star. So what is your Q star R? First element, its power become second element plus 2. Okay? Now we have to take star of that 2 element. Okay. What is star of that 2 element? That first element P as it is, its power become second element plus 2. What is the second element? That is Q raised to R plus 2. Right? That is second element Q raised to R plus 2 and its power plus with 2. Okay? So what is your next step? So your next step become, so A raised to B raised to C. We know that A raised to B raised to C become A raised to B into C. Right? A raised to B raised to C, that is your exponential. A raised to B and whole bracket raised to C become A raised to B into C. Take its product. Same as in this concept. Then we get P raised to Q into r plus 2, right? Again plus with 2 as it is. Okay, so a raised to b, b raised to c become a raised to b into c. Take product of that two exponent, so we have to take product. So what do you next step? So p raised to, take simplify this one, so p raised to qr plus 2q plus 2, call equation 4. This is your p star with q star r. Okay, this is your equation number 4. Similarly, now we have to consider similarly we have to consider p star q. Similarly consider p star q against star with r equal to. Similarly we have to consider p star q inside bracket against star with r. So what is your p star q from equation 1? It gives that p raised to q plus 2, okay, against star with r. Okay, now next step we have to take star of that value. Now from given equation 1 is told that p star q means first element of power below second element plus 2, right? So what is star of that 2? It gives that what is your first element? That is p raised to q plus 2. This is your first element, right? What is your first element? That is p raised to q plus 2 like this. And star become that 2 become first element, its power become second element, right? Its power become second element plus 2. This is your star of that 2 value. That is first element as it is. Take its power is second element is r plus 2. Okay, now simplify this one. Now again use the same exponent rule. A raised to b raised to c become a raised to b into c. That is take product of that two exponents. So p raised to q plus 2 into r plus 2. Okay, take product of that two elements. Now simplify this one. Then we get p raised to q into r is qr plus 2 into r, that is 2r plus 2, called equation number 5. Sorry on this side, this is p star with q against star with r. Okay, this is equation 5. Now from equation 4 and 5, what do you write inside of equation 4? That is p raised to qr plus 2q plus 2. What is right hand side of equation 5? That is p raised to qr, which is same. Here is 2q and here is 2r. So r is not equal to q. Therefore from equation 5 and 4, right? So write down. Therefore from equation 4 and equation 5 we get, from equation 4 and 5 we get p star with q star r is not equal to p star with q against star with r. So both are not equal. That means it does not satisfy associative property. Therefore star is not associative. Star is not associative on z plus. What do you mean by z plus? That is set of positive integer. Therefore given binary operation star is not associative on set of positive integer. These are your whole example. We can check the only that we can take either p and q are two positive integer. Take p is 1 and q is 2. Okay, suppose we have to take p is 1 and q is 2. We can check only that p star q is satisfied commutative and associative. For commutative, we can take value of p is 1 and value of q is 2. So 1 star 2 equal to, so p is 1 raised to 2 plus 2. What is 2 plus 2? 2 plus 2 is 4 and 1 raised to 4 become 1. So what is the value of 1 star 2 is 1. Okay. For other side q star p. So q is 2 and p is 1. So 2 star 1 become, what is the value of q? Q is 2 and P is 1. 1 plus 2 is 3 and 2 raised to 3 is 8. Therefore 1 is not equal to 8. Therefore star is not completed for P is 1 and Q is 2. Similarly for asserting, we can take value of P, Q, R is 1, 2, 3. We can simply check that P star again inside by Q star R is equal to P star Q again star is whole or not. Similarly, the star is not satisfied for 1, 2, 3. If value of 1, 2, 3 become P, Q, R, so therefore star is not associative on set of positive integers. So I hope all parts you have understood from that both example. So remaining part we are studying next lecture. Thank you.